All right, let's get started. Again, my apologies for the difficulties with the link, but it looks like most of the folks have made it, so we will get started. Welcome to the July edition of the Northwest Gas Association webinar. My name is Connor Wrighton, and I'm the Communications Manager with the Northwest Gas Association. Today we're joined by Jason Lambert and Steve Potts of Williams Northwest Pipeline, and they're going to be discussing pipeline safety and how we can maintain pipeline statuses as the safest method of transporting energy. Williams Northwest Pipeline is, of course, a member of the Northwest Gas Association. We want to thank Jason and Steve, as well as the Northwest Gas Association board members, Laren Gersh and Ed Brewer, for helping to get this topic teed up. Before we begin, let's review the basics for how these webinars work. We have set aside some time for questions, and we strongly encourage you to ask them as they come up. Each of you will be muted throughout the presentation, so please use the text box to type your questions, and I will interject as needed to introduce the questions. You should be able to see that text box under the heading chat in the GoToMeeting control panel near the bottom. Jason and Steve have given us permission to convey a PDF copy of this presentation for those who ask for it. You can do that by sending me an email at creiten@nwga.org, and I'll get you a copy before close of business today. We are also recording and we'll upload this to our YouTube channel later, and I'd be happy to send you the link as well. The easiest way to get in touch with me is just to respond to the email that I sent out with the link just a couple minutes ago. As some of you may know, the Northwest Gas Association hosts webinars like these each month. We will not have a webinar in the month of August in the hopes that many of you will be outside enjoying the summer, but we will return in September and have a tentative plan for a webinar on September 14th. We will be in touch with details as we confirm them. As always, we ask that you look way ahead on your calendars and mark off June 6th and 7th for next year's 15th Annual Energy Conference, which is again at Skamania Lodge. And finally, I'd like to introduce the Northwest Gas Association for those of you who might not be familiar with us and what we do. We represent the 6 investor-owned gas utilities operating in the Pacific Northwest, along with the 3 large natural gas transmission lines. Our members are located in Oregon, Washington, Idaho, and British Columbia. As always, please visit our website at nwga.org for more info, or send me an email at creiten@nwga.org. And without further ado, I will pass things along to Williams.
All right, thank you, Connor. I'm just waiting for control of the screen. Perfect, I'm getting it now, so I'll show my screen, and let me know if you can see it. I'm just changing the settings now, and it should be coming through.
Yep, looks great.
Okay. All right. Well, again, thank you, Connor. It's a great opportunity for us from Northwest Pipeline, anyway, to join you on this webinar. As Connor mentioned, I'm joined by Steve Potts. He's by my side. I'll be presenting most of the slides today, but he may help with some questions and answers as we present on pipeline safety and why we can feel confident in the gas transportation through our pipelines. Today, I'd like to kind of step us through kind of the entire cycle of gas pipeline management from a pipeline safety perspective. We'll kind of highlight why we think, or why we know, pipelines are safe through some of the regulatory compliance aspects, and then the construction of a pipeline from the routing perspective all the way through the design and in construction, and then testing of the pipe, and then as we operate and maintain our pipeline, and really highlight the integrity management programs that we implement and execute in compliance with the regulations to ensure that our pipeline integrity program and transportation is safe. And then we'll highlight the public awareness and outreach programs that we as an industry are constantly mindful of and consider that an important topic. So, and then we'll close it with some questions and answers. First of all, I'd like to just start off with the statistic from NWGA, the Interstate Natural Gas Association of America. Northwest Pipeline is a member. I believe there's 18 members in NWGA. Northwest Pipeline is a member, or Williams Gas Pipeline is a member of NWGA. And this is a statistic that I thought was really interesting and worth sharing. that 99.99997% of all gas moved through interstate pipelines is done safely. So we should take a lot of confidence in that statistic, and really shows the credibility and value of our pipeline safety programs. It is considered by NWGA, and I believe they cited the Department of Transportation through a statistic that I couldn't find, but it is considered the safest form of energy transportation in the United States. And then finally, just a note there that we as operators of gas pipelines certainly consider safety our first and foremost priority. It is considered in every step of the way, through our discussions and maintenance of our pipelines, and through that whole cycle of design and maintenance of our pipelines. And here at Williams, I'll just highlight, the first mission, a mission statement, the first one that we have at Williams is that we operate safely in everything that we do every day. And I believe most employees have that posted on their office walls, and so they can constantly be reminded that we need to operate safely in everything that we do. Williams, we also have a stop work authority. Any employee has opportunities. If they feel like anything is not safe or not being done right, they have an opportunity to stop work and reassess the situation and do things safely. And I think that has a lot to do with our safety culture that I'm confident that every one of us as a prudent operator have embedded in our programs and our safety programs. Moving on, so let's just kind of highlight why do we believe natural gas pipelines are safe? Well, there really isn't any one single tool or technique that really provides all the answers. It's a combination of multifaceted approach, all the way from the robust design and construction through our operations and maintenance practices. We are constantly mindful of the need to be safe and constantly questioning, the practices that we employ. We obviously want to make sure that we meet or exceed all of our pipeline safety regulatory compliance expectations. And so we'll highlight a little bit about what that is and how we get into the Department of Transportation rules. But certainly we want to ensure that we meet or exceed, and in many cases we do exceed the pipeline safety regulatory compliance expectations. And then also just to highlight the importance of a strong safety culture that each of us try to develop. Moving on, so on the regulation standpoint, we are regulated as an interstate pipeline by the U.S. Department of Transportation through the Pipeline and Hazardous Materials Safety Administration. We are interstate, Northwest Pipeline is, and we do, in our portfolio of assets, we do have some intrastate pipelines, and those are generally regulated by the state entities themselves. And so that kind of puts in perspective of who our regulators are. It could be a federal regulator or it could be a state, and each of them issue regulations that we're all mindful of. Of course, as a regulator, they track, they ensure that we're in compliance. They conduct audits regularly, and we are obligated to report incidents to them, and they roll up statistics as a nation or for the state as a result of regulations or incidents that we communicate to them or report to them. Through the regulatory compliance, we're required to maintain an effective operations and maintenance manuals that really dictate how we operate as a pipeline, what we do, why we do it, and how it should be done. There's an expectation that we have an operator qualification program, which really details, how we qualify and certify and train those that perform actions on our pipeline. They're expected to be, well trained and implement, things effectively. And we'll also highlight again today the integrity management program. That's a key part of the rule in today's pipeline regulatory atmosphere or environment is the integrity management program. We'll highlight a little bit about that today. And our public outreach and an emergency response. It's all embedded in these regulations that we are always mindful of and being compliant. So all the way through the life cycle of pipelines, from a pipeline routing perspective, we always, whenever we have a chance to to choose or propose where we'd like to route a pipeline, we're always mindful to minimize impacts as much as possible to the environment and to the public. If possible, we try to stay in the same right-of-way with other operating companies, whether it be a pipeline or an electrical utility, if possible, just to I guess, minimize the impact to the community. We're also mindful of the stability of the pipeline route, avoiding geohazards, side hill slopes and other ridgeline alignments where possible to make sure that the integrity of our pipeline is we're putting the pipeline in the best possible spot to minimize incidents in the future. Let's see, if we also do a geotechnical analysis, that goes in with the geohazards approach to make sure that we're mindful of those and ensure it's safe to construct. Okay, let's move on to kind of the building aspect of the pipeline. We have proven design standards and practices that we as an industry collaborate on. There's the American Petroleum Institute that has standards that we try to abide by, and sometimes those are cited by regulations that we need to comply with. These have been tested and improved over time, and so we're continually getting better on how we design these pipelines. Of course, a pipeline is constructed by high yield strength pipe with substantial wall thickness to ensure that the gas stays in the pipeline. We X-ray 100% of the wells when they're constructed, and before they're placed into service, the pipeline is tested at a pressure higher than normal operating pressures. So we have a sense of assurance that the pipeline, if there's any defect, it's going to be found through a pressure test before it's being placed in service, before gas is moved throughout the pipeline. And then we want to make sure that we kind of have a barrier of cover on top of us, so we try to have a 36-inch cover on top of our pipeline. That's according to the regulation. So one aspect of pipeline design and construction is the term class location. It's a term in the Department of Transportation. It's a regulatory compliant activity that we do. What this consists of is well, let me just step back. So class location has a lot to do with how we design our pipeline and the qualification test pressure that the pipeline will see before we place the pipeline into service, the operating pressure that the pipe has, that's kind of basically the limit of pressure that we can pressure up that pipe up to, any odorization or putting an odorant in the pipeline so that others, if there's a leak, that they could be mindful of that's natural gas. So it affects odorization, it affects the spacing of our block valves in our pipeline and the leak surveys. So class location is an important pipeline safety technical analysis, and without getting too technical, I'll try to step everyone through kind of what the class location study consists of. And really, it's a sliding mile. So if you can imagine a ruler that slides along the pipeline that's 1 mile long, it does a count of the homes within that sliding mile as you move that ruler or that sliding mile down the pipeline. And so this graphic here that we see here is that first green line moving left to right. We can see that sliding mile would start at that home that's near our pipeline, and it would go 1 mile down the pipeline, and it would count all the homes within that sliding mile. And then it would go to the next home and count the next home down. And as it moves down, the more homes that are captured or identified within each sliding mile, we increase a class location. So a class 1 area would be 10 or fewer homes intended for human occupancy in that sliding mile. A class 2, if you have a sliding mile with 11 to 45, then it becomes a class 2, and it increases in, class 3 would be 46 or more structures, or within 300 feet of a high occupancy building. And so you can see that we have to be very mindful of what is surrounding our pipeline right away. What is the buildings around our pipeline. So we constantly monitor the pipeline right-of-way area, if you will, and to do an analysis of what is around our pipeline to determine our class location. And then also, if there's a class location that's built maybe as a class 1 pipeline, but then more homes are moved in, we capture that growth of population around our pipeline, and according to the rule, we might have to either rehydrotest a particular section of pipe because the initial pressure test done at a class 1 area is not high enough to suffice for a class 2 area, and so we would have to either rehydrotest that pipeline to revalidate that maximum allowable operating pressure, or in some cases we might have to replace the pipeline, a segment of pipeline itself, because the wall thickness is not strong enough to withstand the pressure test that we have to achieve in order to maintain that pipe at that pressure. So that's important that we understand that when we're talking about pipeline design is the term of class location. Let's move on to, well, I highlighted a little bit the pipeline qualification testing. So when we hydrostatically test a pipe, most means of testing a pipe is through water, through hydrostatic testing. And so in a class 1 area, we would need to achieve a hydrostatic test of 1.1 times the highest allowable pressure that we can that we will be able to operate that pipeline at. So you can see as we move to a class 2, that factor increases so that we're having more confidence in our pipeline integrity as we get into a higher occupancy area. Class 3 goes into 1.3 or 1.5, excuse me, and class 4 sees the same test pressure. But I will note that a class 4 area are quite rare. You really have to be in a very highly densely populated area for a class 4. And they see the same test factor, or excuse me, the same ratio of 1 as class 3, but a class 4, there's a design factor in there that they would have to have a higher design factor for pipe. So that's another measure that we have for class 4.
Hey, Jason, before we move on, we do have a question here. If you're ready.
Okay.
I think it's relative to your to slide number 8. And the question asker says, I'm aware that contractors have to train to be in compliance with some of the more general standards for covered tasks, but also have to be up to date on operator-specific requirements. Can you give some examples of some Williams-specific approaches that contractors and employees have to learn?
Yeah, this is Steve Potts here. I'll just give a couple quick examples. On the construction side, the welders would need to be qualified in the welding procedure. People conducting the hydro test would have to be qualified. And on the operations side, it would be valve maintenance, right-of-way inspections, and that type of thing would all be covered under the OpQual rule.
Great, thank you.
Okay. All right. Good question. Okay, I believe I'm on the pipeline coding slide. So after the pipeline is been tested and let me just back up. Previously, years ago, when pipeline came out of the factory, it just came as pipe without coating on it. The coating is now placed. Most cases, pipe out of the mill comes with the coating on it, and the whole point of coating, pipeline coating, is to form a barrier against corrosion that will prevent or mitigate the metal loss of leaving the pipe and going to the natural earth. So we do have a couple of forms of coating. Obviously, I've mentioned before, most cases now it comes out of the pipe mill already with coating on it through a fusion bonded epoxy, which is a really strong epoxy that prevents the corrosion. And then also it is applied in the field as well as a two-part epoxy for enhancement. You'll notice that in the lower left corner of that slide, you can notice that the factory applied coating is already on that pipeline. It's typically a green coating for the fusion bonded epoxy. and then the weld sections areas are not coated. Those get coated in the field after the welding is done. And so the photograph on the right, you'll see a gentleman who is applying a 2-part epoxy in the field. So coating is an important factor of pipeline safety. There's no question. It prevents corrosion from our pipeline. So after we, so to speak, have the pipeline in the ground and we've inspected it and we're operating it, there's a number of things that we do as an operating company to maintain the integrity of the pipe and prevent that gas from escaping in any way. Certainly a large factor is just patrolling the right-of-way, putting eyes on the right-of-way, making sure that we don't see anything abnormal. We, depending on the class location, we perform more frequent surveys, if you will, to inspect the pipeline for leaks. I know annually we fly a right-of-way in a plane and assess all the pipe visually. And another factor is, of course, line markers. We want to make sure that the public is aware of where our pipeline is at, making sure those are maintained and up so the public knows that. Significant factor is our 24-hour monitoring through our pipeline control center or gas control center. I know Northwest Pipeline's office out of here in Salt Lake City. They monitor from that control room all the gas operations, gas flows through the entire system, and through the SCADA system, the supervisory control and data acquisition system. They can see if there's a drop in pressure, and they can immediately take action to maintain the safety to the public if there's an incident. Certainly, one call is a big factor that we'll talk about a little bit later. But certainly, as we kick off the section of operations and maintenance, there's a number of activities that we do to keep our pipeline safe. To jump into the integrity management program, because that's certainly a another question?
Yeah, we've got an interesting one here with reference to the Class 1 and the Class 2 classifications. If you, say, have an area that is developed from a Class 1 and then becomes a Class 2, then do you go back and upgrade those pipes to reflect that change?
That's a great question. Generally speaking, if we install a pipe, we try to hydrostatically test that pipe to enough pressure that if one day enough people move around that pipeline, then, or if there's an encroachment, if you will, or density increase, that pipe is already good enough, so to speak, or has been tested to the pressure high enough to be operating at the Class 2 level. If for whatever reason we did not test the pipe high enough when we installed the pipe during original construction, and we needed a higher test, then absolutely we would go in there and do it and perform another hydrostatic test to achieve the appropriate level that we need to. And if the pipe is not designed to achieve that level, then we would replace the pipe so that we'd have higher thickness, higher grade steel in the ground so that we could achieve that pressure.
Yeah, does that answer the question?
I believe so. If it doesn't, it does. Yes. Thank you.
Okay. All right. Good question. All right. I'm on the integrity management program slide. The integrity management program is fairly new, not horribly new, but it came out in 2004 as a result of a rule change by the Department of Transportation. It requires that a pipeline company like ours, we have a risk-based plan of assessing and mitigating threats to pipelines in what they call high consequence areas. And so what we do is we do a survey similar to a class location study with density or population around our pipeline. We perform a study where we identify what the rule calls an identified site, which is if there are any limited mobility sites, such as a hospital or a school or a retirement center or a daycare, a prison falls into that as well. Any site that would have a limited mobility, it's termed as an identified site. And if it's within a certain radius of our pipeline, which is called the potential impact radius, or PIR, and the PIR is a factor of our diameter and our operating pressure. And if a identified site falls within the PIR, then that causes a high consequence area. Or it doesn't have to be an identified site. It could be a cluster of 20 or more homes within the potential impact radius. So you can imagine, similar to a class location, you're constantly moving down the pipeline, and we have software that does this for us through a geographic information system, but it will constantly, based on our survey, do the math for us on the potential impact radius, and if there's a identified site, or if there's a cluster of 20 or more homes, or sites that are intended for human occupancy, kind of a technical term there, but that's straight from the code. Then we have an HCA, and so the longer as that PIR moves along the pipeline, we no longer have that case where the identified site or an HCA exists, then an HCA would no longer be present. So that's an important thing is that we do and maintain the surveillance of our pipeline and the occupancy around it. So with those HCAs, I'll move over to the next slide where we've identified an HCA, and the IMP rule requires that, or in the rule came out in 2004, it required that all the HCAs be assessed by December 2012. And they could have been assessed through 3 different means, generally. They could have been assessed through an inline inspection, or I've got some slides later on that talk about, that show what that consists of, or it could be a pressure test, similar to a hydrostatic test, or a direct assessment. Basically, we're ensuring that the pipeline integrity is solid, that it is, and we're constantly, continually, evaluating the threats to our pipeline along these HCAs. The rule required that after it was initially assessed by 2012, every 7 years thereafter, we would have to assess the pipeline according to the threat that we perceive the pipeline might be facing, such as corrosion, cracking, or other defects. Another threat that we face is human error, so excavation damage. HCAs come into play when we reach out to our public, the general public. We do more extensive outreach in HCAs than in other areas. We also monitor the threat of weather and other earth movements. Now, I will say that just because a particular segment of pipe isn't considered an HCA on the technical term from the code, that doesn't say that we don't, execute on integrity management principles. We'll talk about inline inspection, how much of our pipeline is assessed that is not an HCA through either inline inspection or pressure testing or direct assessment. So
Jason, can you give an example of direct assessment?
So this is Steve here again. The rule allows direct assessment. So what direct assessment involves is some engineering survey. So where you typically might use direct assessment is on a pipeline that is not piggable. So it has a lot of tight bends and fittings on it, and it's not practical, or it's really short. It might be a few hundred feet, and it's not practical to run a pig. So the rule allows you to do an engineering assessment to identify what your risks are. Are they external corrosion, internal corrosion, third-party damage, what have you? You identify what your risks are, and then you can conduct some engineering surveys to point you where you want to dig on that pipeline. So you might do some close interval survey studies on that pipeline and find an area of low potentials, which Jason is going to talk about the cathodic protection systems a little closer, but you might find some areas that have lower cathodic protection levels, and that might tell you where to dig, and you go do direct assessment. So you dig up the pipeline and inspect the coating and then the condition of the steel itself. You document it, and that is what is referred to as a direct pipeline assessment.
Great. Thank you, Steve.
All right, good question. On this integrity management slide, I just threw in a couple of photos of what an inline inspection tool looks like. These are commonly called pigs, just because they make that squeaking noise. If you're standing above the pipe, if in a pig passed by, it would kind of squeak at you. So it's kind of why the industry calls them pigs. But there's various types of pigs. The first pig I'll mention is a geometry pig, which we run through the pipeline, which assesses the pipeline for dents or any deformations that might exist in the pipeline. The other type is the most significant one, at least has been in the past, and with other technologies, there's another one coming up. But this magnetic flux leakage, or an MFL pig, really looks at the internal and external corrosion of the pipeline. It's been a very valuable pig and type in inline inspection, and it's been very useful for our integrity management program. The third one that I'd like to just highlight is a kind of a newer technology of an inline inspection or a pig. It's called the electromagnetic acoustic transducer, or EMAT, and it's being deployed throughout the industry now for monitoring and analyzing any conditions of stress corrosion cracking along the pipeline, or and any seam weld anomalies that might exist. So industry is advancing. There's technology is continually advancing, and it's fascinating to see how we can analyze these systems. I will add that one thing I didn't hit on, when the rule came out in 2004, that we are to assess the inline, or assess our pipeline by 2012. Most companies all companies that had to apply to the rule and wanted to use inline inspection had to make many modifications to their pipeline systems in order to run these pigs. As you can see, that they are launched through the pipeline through what we call the launcher, and they're received through a receiver. And of course, that's capital cost that we covered, that we have to spend to run these pigs or make them, quote, piggable. And so that's quite an investment, and industry has found a tremendous amount of value from that. But there has been a significant amount of cost, as you can imagine, through the integrity management program. I will move on here to cathodic protection. This is basically cathodic protection is a fancy name of basically mitigating the loss of steel from our pipeline that's going to the earth, because naturally, if you bury a pipeline in the earth and just let it sit, it's just naturally going to corrode. And so what we try to do is we try to send a low voltage current to the pipeline to minimize that loss. If there is a defect in the coating for whatever reason, we want to make sure that that steel on that pipeline is not corroding into the earth. So this technology called cathodic protection allows us to send pipeline or electrons, not to get too technical, to the pipeline that would prevent the loss of metal loss from the pipeline. So that graphic there might be a little fuzzy. I couldn't find a better graphic there, but it basically just shows the current coming from an anode going to the pipeline, and it's protecting the loss of steel to our pipeline. And we constantly monitor, the level of effectiveness that the pipe is seeing, to make sure that our systems are running effectively through a technical program or evaluation of that section of pipe, if we have one deployed. Okay, so now let's get into the public awareness program. Certainly a really crucial part of public safety, or the pipeline safety, how we engage with the general public and make sure that they're aware of our pipeline, and how we can all work together to make sure that it's safe and delivering gas to the markets that we need it to get to. First one I'd like to highlight would be our emergency responders. Certainly critical that we engage with them, so that we, well, most importantly, those who live near our pipeline, to make sure that they know how to keep our pipeline safe without digging into our pipeline. Of course, the 811 Call Before You Dig program. We sponsor activities so that the public is well aware of that. We have a program that specifically targets them so that they are aware of the need to call 811. We reach out to our excavators to make sure the same things, that they're aware of that, safe digging practices, etc. Public officials and emergency responders, we want to make sure that we're all aware of the pipelines and how we can work together to make them safe. So what's the message that we try to reach out and engage with them? Well, it depends on the audience, but really we want to be able to know what the status is of our pipeline. So if there's a particular threat that is threatening our pipeline, such as a excavation going on that the general public might feel is not safe, we want them to know that they can call the 24/7 pipeline control room, and we can immediately dispatch personnel to the site to assess the situation. Pipeline markers, as you mentioned, are important. Notifications to them. We also like to inform them of our integrity management program. What are we doing to keep our pipeline safe? It's important that everyone understands that we're all in this together to keep our pipeline safe, and the trust that we should have in our pipelines. The national I'll mention at the bottom there, the National Pipeline Mapping System, or NPMS. That's an online site that the general public can go to get information about where the pipeline is at, generally speaking, and in their neighborhood, so that they're aware of where a natural gas pipeline might be in their neighborhood. Okay, excavation damage. That's really a key threat to us. And there's a statistic that we got from the Department of Transportation. Secretary Fox said in 2016 that excavation damage is a leading cause of serious pipeline incidents, is a leading cause of pipeline incidents that cause death, injuries, and property damage. So we really focus on our excavation outreach and make sure. Unfortunately, we've had between 1988 and 2014 1,815 pipeline incidents. That's unfortunate. 193 deaths and significant amount of injuries and money lost there. So certainly an important thing that we want to make sure that we are communicating well. And as far as regulatory enforcement, I know the state and federal agencies are increasing their enforcement on these, those that I guess do not follow by the rules or aren't obeying the law, because you can imagine the significant risk that they're putting themselves at and the general public if they do not follow the proper practices and laws. Finally, I'll focus on I'll hit on emergency response and planning. Obviously, we have strong engagement with our emergency response community. We offer site-specific awareness for a particular fire district that is in the area. We want them to know about what we would need to be mindful of in the event that there was something that were to go wrong, and what kind of hazardous materials that we have on site, what they need, what the priorities if there was an incident, how we can engage with them. We exercise with them often. We do tabletops and full-scale exercises. And one of the key things that we found success with as we exercise with them is the use of the incident command system through the FEMA practices of managing an incident. If there ever was to occur, how do we coordinate best so that we know who's on first, so to speak, who's doing what, and how we can coordinate together as a team. It's certainly an important thing. Highlight the new Department of Transportation rule that's pending. There is a significant mega rule, so to speak, that has been proposed by the Department of Transportation. It's gone through an advance notice of proposed rulemaking to increase the regulations on our pipeline. It really was spurred by the unfortunate event of San Bruno failure in 2010 near San Francisco. But the notice the notice of proposed rulemaking came out in 2016, and the final rule is yet to be actually published, but we don't expect it this year. We certainly don't expect it before 2018, January 2018, but we do have some strong collaboration with industry and the government agencies on what necessary measures make sense as far as a final rule goes. But I'll just highlight a couple of things that they're proposing to increase as far as regulation. A Class 1 area, instead of being a 1.1 hydro test rule factor, it would raise that to a 1.25. There's an expansion of the integrity management program to increase the assessment intervals in the risk model and the data integration that's expected from the integrity management program. If you remember the high consequence areas or HCAs, they're proposing a moderate consequence area, which the operating company would be expected to run. So there would be an MCA, which would be a less risky, so to speak, area, which would be triggered by, instead of 20 homes in the PIR, it would be triggered by 5 homes in the PIR. Or if we have an occupied site or a major roadway there, that would also trigger an MCA. And MCAs would come with stricter or the appropriate inline inspection or criteria and other things that would come to that. Repair criteria would be expanded to non-HCA segments. What are currently non-HCA segments now. There's based on our integrity management assessments, we would repair those at a more frequent rate than what we're currently doing now. And records, that's an important thing, making sure that we have records that can document what type of pipe that we have in the ground, the hydrostatic testing records that it's gone through. That's an important thing that industry will be expected to comply with. And verification of our operating pressures or MAOPs. There would be elimination of the grandfather clause, which basically, going back in time, regulation has said that if we can document that we have been operating a pipeline at a particular pressure before these more stringent hydrostatic test records came out, then we could basically be grandfathered with that pressure. We would be that would no longer be in play with the rule. We would have to document that in HCAs, MCAs, or Class 3 or 4. And then management of change, expanding the scope of making sure that we're all aware of all the significant operating changes that occur on our pipeline. Well, that's the final slide. Just to summarize, this is a multifaceted approach, all the way from survey to construction and inspection to operations and maintenance procedures and plans, integrity management, and continually monitoring and the integrity of our pipeline. So with that, Connor, I will open it up if there's any questions that people have.
Yes, we did just get one question in here, and I'll just read it here. Regarding PHMSA's proposed gas transmission and gathering line, what do you guys make of the rule as proposed, and have you been following PHMSA's Technical Advisory Committee's recommendations on changes to the regulation? There's a second part to the question, which is, do you see the Trump administration's policies having an effect on pipeline safety rule development?
Okay, great. Yes, we are collaborating with the GPAC through the technical advisory committees. It fails me the GPAC acronym, the full name, but what the GPAC is, it's basically a group of folks that collaborate on the rules, making sure that they're effective and that we can get agreement on the rules. Yes, Williams is involved with INGA and the GPAC on submitting a comment back to PHMSA, and I'm not sure exactly how far we go into our technical compliance with what the GPAC is recommending now. I know that we certainly will make changes if we need to obviously comply with the rule. So I hope that addresses the first question. The second question regarding President Trump, I'm not aware. I know that there's been some rumors out there that Trump, the 2-for-1 policy, the 2 regulations for 1, and anything on hold is going to be stayed, so to speak, until 2 come off the books. I don't see this. I don't see this slowing down. Well, I don't see it not happening. I see this rule coming out. President Trump probably has something to do with the delay in the rule, because it was expected to come out earlier and it is delayed. But I believe this rule is coming, and industry is preparing for it. and we're collaborating with PHMSA to make sure that we get it right from a risk perspective. So
I would just add that I'm not sure that Trump is delaying it. This rule has been delayed and late coming since San Bruno, right? Jason mentioned the San Bruno incident in 2010. The NTSB ordered PHMSA to produce a new rule shortly after that, and it took, can't remember how many years to actually publish a draft rule, but PHMSA was very late with this rule, much before Trump was even involved, and so I believe it's the complexity of the rule, the broad scope of the rule that has really delayed it. It's a very highly technical rule change with a lot of implications, so there's been a lot of input and a lot of analysis. I think that's the major point of delay.
Great. We've got one more question here. In cathodic protection, what is a typical distance between the protective anodes?
That's a good question. There's no typical distance because it's really dependent on soil conditions and moisture conditions. So if you have a brand new pipeline that goes into the ground with good coatings, and you go in and do your cathodic protection survey, your first survey, and you've got a good coating system, you're not going to need a lot of cathodic protection and ground beds. Now, if you're dealing with an older line that isn't as good of coating, you're going to have more leakage, more coating defects. When you do your cathodic protection surveys on that line, it's going to dictate closer spacing. And then if you're in a rocky, dry terrain where the current doesn't pass through the ground very well, then your spacing is going to be even tighter. So there's no real good answer on the typical spacing. It's really going to be driven by environment.
Great, and that's the last question that we have right now. If anybody has any other questions, I encourage you to type them quickly now. In the meantime, I want to thank the two of you for your help in putting this together. I know you're both very busy and appreciate the information that we all got today. Also want to remind folks that if you send me an email, I'd be happy to send you a PDF version of this slide deck. We'll be uploading this to YouTube here in the next hour or so, and I'll do my best to respond with those things in the next couple of days. So in the absence of other questions, again, just wanted to thank you guys and encourage everybody to have a great month of August before we come back for our next one in September.
all right, well, thank you, Connor. It's been a pleasure, and look forward to maybe answering any questions that might come later.
Sure. Yeah, much appreciated, and we'll see everyone in a couple of months.
Thank you.